Hello students, let us talk today about semester 3 unit 1 convergence of sequences related to mathematics. We are discussing today Cauchy sequence. Cauchy sequence, its definition, let Sn in curly bracket from n is equal to 1 to infinity be a sequence of real numbers, then Sn and from n is equal to 1 to infinity is said to be a Cauchy sequence. Means this sequence is said to be a Cauchy sequence if for each epsilon is greater than 0. This is epsilon sign which is greater than 0, means it is any positive value greater than 0. There is an n0, one particular value n0, which is element of natural number n, such that mod of Sm minus Sn is less than epsilon for all mn is greater than or equal to n0, where n0 is element of n. So if m comma n is greater than or equal to n0, then in that case Sm minus Sn mod is less than epsilon. Means this is one finite value and this value is less than that finite value. It is mentioned here. If this case exists, then this sequence which is defined by this is said to be a Cauchy sequence. Once again I am explaining by another definition. A sequence Sn from n is equal to 1 to infinity is said to be a Cauchy sequence if for each epsilon is greater than 0. Up to here it is just like that only, which was defined in the previous definition. There exists a positive integer n. Here the integer is changed, one positive integer n, such that it is introduced one positive integer n, such that in which manner Sn plus p minus Sn, means here in place of m, n plus p we have written, which is less than epsilon. Its mod is less than epsilon, or mod of Sn plus p minus Sn is less than epsilon for each p is greater than 0, where this value p which is mentioned here is greater than 0, means we mean to say that this sequence is having more terms as compared to this sequence, because here it is n plus p and p is already mentioned that it is greater than 0, means what? It is having more terms as compared to this one. So it is well clear from here also that it should be less than epsilon, means one finite value will be there, but less than that finite value only this particular value will exist. So its example, by example we can explain it. The sequence 1, 1 by 2, 1 by 3, dash 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 and 1 by n and dash 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 is a Cauchy sequence. It is known as Cauchy sequence because if m is greater than n, suppose this value of m is greater than n, then if we are taking mod sign here, mod sign means what? It will make the positive sign also positive and negative also positive. It will make the negative sign positive and positive already. If it is having, then it is positive only. So 1 upon mod of 1 upon m minus 1 upon m will be, it is actually n minus m upon mn, but mod is there. So we are mentioning because we have mentioned m is greater than n. That's why we are introducing here m minus n. M in starting and n as a second term, because m is greater than n. So this should be any positive value. If we write here n minus m, then in that case there is no use of mod, because m is already given that it is greater than n, this value of m. So m minus n upon mn is less than 1 upon n, means one definite value here it is, or one finite value here, and this value is less than that particular finite value. Then if epsilon is greater than 0, be given, suppose here epsilon is greater than 0 is given, and then we are taking n0 is less than 1 upon epsilon. If we are taking n0 which is less than 1 upon epsilon, we can get that, means it is taken as 1 upon epsilon here, n0. So if we replace both the values, then this will be replaced by epsilon. So it will become, and this is the solved part of this one. So mod of 1 upon m minus 1 upon n is less than epsilon for all mn is greater than n0. So this shows that given sequence is a Cauchy sequence. So I have explained you here the definition of Cauchy sequence by in two manners, and by giving one example also I have explained it. So this Cauchy sequence definition is now over. Now see the next topic, convergence of a sequence. Let Sn from n is equal to 1 to infinity, means it is sequence, be a sequence of real numbers. It is the sequence of a real number which is defined by Sn from n is equal to 1 to infinity. Then the sequence Sn from n is equal to 1 to infinity is said to be convergent. It is called convergent sequence if the limit of the sequence is finite, which can be counted, we can say. That is known as finite. If the limit of such a sequence is finite and a definite number L, one particular definite number will be there, that definite number is assigned as L, then we can say it in another manner, that is, if limit n tends to infinity, Sn is having one particular definite number as a limit up to, if we solve it up to infinity, this particular sequence, then we will get one particular finite value after solving this limit, then it is called as convergent, convergent sequence we can say, or convergence of a sequence is there. If Sn does not converge to a finite limit, if it is not converged to any finite limit, then what happens? Then the sequence is said to be divergent. If we are not having any finite value after solving this limit up to infinity in this sequence, then we can say that it is the divergent sequence, or if finite limit does not exist, then we can say that it is divergent sequence. Divergent sequences are of two types. There are two types of divergent sequences. One divergent sequence is called properly divergent sequence. Properly divergent sequence means if limit n tends to infinity is either having plus infinity value or minus infinity value, then the sequence Sn from n is equal to 1 to infinity is said to be properly divergent. Means after solving this limit, if we get either positive infinity or negative infinity, then it is known as properly divergent sequence. And another type, this is first type, which is called properly divergent sequence. Now second type, oscillating sequence. If limit n tends to infinity, Sn is not definite, means not having one particular value. Definite means what? If L is mentioned here, then it is definite value. If there is no definite value, means we can say in that case, then the sequence Sn from n is equal to 1 to infinity is said to be a oscillating sequence. Suppose I am giving one example of this. Suppose I am writing here minus 1 raised to the power n. So if it is having 1 as power, then we will get 1 minus 1. If we are having power 2 here, then it will be minus 1 square, then it will be positive 1. Again 3 will be there, then it will become again negative. Means for all odd numbers we will get minus 1 as a result. And if we are having power even number or index even number, in that case we will get plus 1. So such type of sequence is known as oscillating sequence, which is not having any definite value after solving the limit up to infinity. Then such type of sequence is called oscillating sequence. So up to here only we end over this topic, convergence of sequence and divergence of sequence, and with two types also I have explained these two topics to you. And thanks a lot for watching our channel. Please do like it and subscribe it.